All right. Hello, welcome. So today we're going to talk about really solving initial value problems. I should say using the Laplace transform. So I will give you a couple of problems from 7.4 homework, but I'm not really going to officially cover 7.4 because we sort of get it for free um, as part of 7.5. So buy an order of 7.5 and you get 7.4 for free. Okay. All right. So let's start with just a really easy problem that we know how to solve ideally. Okay. So let's take as sort of our model problem. Okay. Just y double prime plus omega squared y equals 0 with y of 0 equals a and y prime of 0 equals b. So we know how to solve this, so everyone can do that. I'm going to go ahead and I'm going to solve it via Laplace transforms. Okay, so we got a couple of things. So let's start. I like to start by taking the Laplace transform of everything I need first. So L of y, we're just going to call that, I'm going to call it y with cursive. Okay, capital Y with cursive. They use big Y's in the book, but I have trouble differentiating between little y's and big Y's, so I do try to make it a little different. Okay. L of y double prime equals, so L of y double prime, we may remember, let's take a look. I looked here. Nope, I don't have it here, but we did do it the other day. So this is going to be s squared y minus s y of 0 minus y prime of 0. So in this case, it's going to be s squared script y, which is again the Laplace transform of y, minus as minus b. Okay, so let me highlight this. Okay, I don't have anything else. So I'm going to put this equation into Laplace transform form, and we get, so let's take our dE, or actually the whole initial value problem. Okay, so our initial value problem becomes a matter of, this is our new equation. So we're going to take s squared y minus as minus b. That's the y double prime plus omega squared y equals 0. And we don't actually have to worry about initial values. I mean, we do, but they're already sort of involved, right? We've already worried about the initial conditions. Okay, so now we're going to solve for y. So we get s squared plus omega squared y equals, on the other side we get as plus b. Okay, now here one thing I want to point out is that you're going to get an algebraic equation here, and that algebraic equation should match with the characteristic equation of your original differential equation. Okay, now we're going to take and we're going to solve for y. So y equals as over s squared plus omega squared plus b over s squared plus omega squared. Okay, and now we're going to take the inverse for Laplace transform, sorry, I almost said Fourier, inverse Laplace transform of these things. Okay, so our y is going to be the inverse Laplace transform of this mess. Not mess, this stuff. Okay, now, one of the things is that we have to sort of see is that the Laplace transform and the inverse Laplace transform are linear. So that means we can just take the different pieces and find the Laplace transform of each different piece. So this is going to be the Laplace transform of AS, S squared plus omega squared, plus the Laplace transform, inverse Laplace transform, sorry, of B over S squared plus omega squared. Now I'm going to look on my Laplace transform chart. Unfortunately, I couldn't find a formula to take the inverse Laplace transform. The only thing we can do is look at a chart. So we look. Now I know what I'm looking for. I kind of know this is going to be sines and cosines, right? So it's going to be easy for me to see, oh, look, 24 and 25 on this thing, okay? Sine of bt has Laplace transform b over s squared plus b squared. Cosine of bt has Laplace transform s over s squared plus b squared. Let me write those down. So the Laplace transform of sine of bt equals b over s squared plus b squared. And the Laplace transform of cosine bt, I always have to rewrite them s over s squared plus b squared. Okay, so look, this one kind of looks like it's going to be a cosine after pulling out this a. And this one I'm going to have to play with a little bit too, but it's going to be a sine. Okay, so we get a cosine of, instead of b, it's omega. And here we're going to have plus b over omega sine of omega t. Okay, and that's the answer we should expect for this differential equation, for this initial value problem. All right, I'll see you in the next video. That's going to be the easiest problem today, just to let you guys know, fair warning.